that you will get an interest in knowing more about the topics. Then I will move to development of customized protocols for web robotics and their characterization. This is a very important area because see, most of these developments in web robotics are through customized protocol. So we need very specialized customized protocol, and most of the time it should be indigenous. At least the examples that I will be citing today are all indigenous. A to Z is indigenous of my own development from the concept along with my scholars and students. Modeling of the algorithms are also very important because algorithm cannot be developed without a good sound theoretical models, and then once the algorithm is ready, we need to translate in the form of a programming sequence and protocol sequence. So we'll see to some analysis. Dynamic control and reliability of real-time web robotic systems with the data analysis. So this is important paradigm because whatever the robotic systems that we'll be talking about, whether it is a full-fledged robot or a robotic sensors or some part of the assembly, we need to have real-time data analysis. This real-time data analysis is a very important part because statistics is also involved in that. So we have to put several parameters in unison actually. So I will not go to detail because each of these subjects is a very intense area. So within the time limit, we cannot do justice to that, but to the best possible extent, I will give you the highlights of that. Then some simulation and experimentation on various robotic gripper systems via LAN and internet. So this is also a very important tooling because a sizable portion of my own research is in gripper toolings, robotic gripper systems. So I will give some briefing on those during the course of my talk, and we'll conclude afterwards. So basically the idea is this subject is having high research quotient. So that is one of the important things that I should speak in this FDP because it is for the research opportunities. So it is all these topics have got research quotient and highly multidisciplinary domain with many open issues. So as you know that research must will have open issues. Unless until there are open issues, there are gap areas, there is no point in doing the actual good R&D, good research. So these are highly multidisciplinary domains with many open issues. So let us go to the different research branches that we can think of in the subject area of web-mediated robotics. So I will go a little slow here because each and every keyword is important. Later on, we'll explain the things. So first group is web-based robotic technology. That means what are the basic robotic technology which were developed in our country, say from 80s and maybe late 70s also. And then what we can improve upon today with the web-based technology. First group is remote actuation. Then second is teleoperation. Third is internet telerobotics. And fourth is network robotics. So all these four modules are very, very important. And in a Department of Atomic Energy, we do practice at least two of these groups, what is basically the remote actuations and to some extent internet telerobotics. Then group B is web-based control of solo robot, where we can have a concept of variable reliability based actuation protocol. This is my own development, from the concept to the realization, and it is a very successful protocol. It is based on variable reliability. I will dwell on it for a sizable time, and this is for the solo robot. That is, there is a single robotic system is in actuation. We can control the things by this variable reliability based protocol. Then third is for team robots, where control semantics can be through the web. So in today's domain, there are a lot of team robotic systems are coming. You know that RoboSoccer is coming. There are Robocon competitions all over the world. So this team robots concept was not there in the early 20 years or 30 years of robotics development. But today, these things are coming, although these are mostly in academics till date, but there will be sizable applications in near future in social sectors and in hospitalization sectors, hospitality sectors also with the team robot. So we need to have a web-based mechanism for this controlling of this team robot. So I have grouped three major items of research here. C1 is synchronized animation transport protocol. It is also SATP, I call it, my own development. Image and animation induced transmission protocols, ITP and ATP. And dynamic switching between protocols for coordinated control. This is also another very important topic. We'll dwell on that. Fourth segment of web-mediated robotics is database management for web-based control. So this is very, very important as you are controlling various robots through web, and it goes very synonymically that when it is through web-based control or net-based actuation, we can always think of many robots at a time. Okay, so then the database management comes in the picture. So this is very important aspect, and there should be a good amount of research in this sector also. So D1 is access of robotic systems through multiple inputs, then remote access of databases, design and development of customized search engines. So these are also very important, that we can have a specialized search engine for robotic systems only, and application of data mining tools. Fifth group of vertical is network related issues in web robotics. So these days, this is very important because there will be a global acceptance of web mediated robotic principles. So we need to have a good network connectivity along the kind of a physical geographical separation and physical boundaries. So number first of the E1, I am calling it, is the interesting development. It is localization of remote web servers through dynamic port address translation, or the DPAT. Hello, I think there is some other mic is coming. Hello.
Hello, sir. Hello.
See, there are other sounds are coming, so kindly look at it. I think somebody's microphone is on. Hello. Okay, fine.
Yes, sir.
So
Yes, sir.
E2 is yeah, fine. E2 is routing table poisoning, a new metric for troubleshooting. This is also very important concept. I will dwell on it. Semantics of M2TP, which is multicast mixer translator protocol. This is also an interesting protocol in network related things. C-code communication in wide area network, which is basically P3M, and wireless internet telerobotics. So these are very recent areas, of course, so a lot of research can be addressed here. Then sixth vertical is real-time robotic system via multiple input, multiple output. So data structure and format, algorithms for intake of multiple inputs, and systemization for multiple outputs. Sorry. Then sixth is the future of web robotics, which is assistive robotics, bio-inspired robotics, and rescue and rehabilitation robotics. So this is also very important because although this domain is still in nascent stage, I should say, but it is already coming in the picture of G1, that is assistive robotics. People are using web robotics concepts already. So what are the objectives of research in this web mediated robotics topic? So I will just list down the things and then I will explain the things. So basically, building up an insight towards critical design issues in web-mediated robotic actuation. So this is called WMRA, web-mediated robotic actuation. So we have to have a critical design build-up. Challenges faced towards design and development of customized protocol for successful operations using robotic systems. So please understand the basic core of this development of this subject, web-mediated robotics, is development of various customized protocols for actuation of this. So these actuations are very important, and customization of these protocols are also very important. Issues concerning development of intelligent databases, data mining, information sharing over the World Wide Web pertaining to robotic operations, and building up an application-driven thematic for the development of web-mediated robotic actuation in real time. So invention of new protocols tailor-made for successful performance of the system. So these are the objectives. So that means basically we have to have a domain of WMRA, web-mediated robotic actuations, with the help of various customization of protocols Often these protocols are to be based in World Wide Web, but one has to try from the local area network or the wide area network to start with. And these are the paradigms of research. Now, for this, the first important tool in our hand will be distributed generic architecture of the web-based remote activation system. That means whenever we have to think that we have to actuate this particular mechatronic system, say robot or any other similar gadgets, mechatronic gadgets, we have to have a architecture ready for the algorithm of this operation. This is known as DGA or the distributed generic architecture. So this is very, very important to start with. That means what we want to do, what this robot is intended for, whether it is for pick and place operation or any industrial job, is it for material handling or is it for some kind of a assistance or tooling. So these concepts are very, very important. Based on that, you can think of what kind of a suitable protocol is required, or we can use the existing protocols as well. So this architecture is very important. And also architecture means how many users are connected to these robotic systems. So which is essentially our basic concepts of client and server. That means how many clients. That means how many users are there. And what is the server? That means how many server or what is the server for that. So this client server architecture is also very important for actuation. So basically these robotic systems are experimented out. Now the issue that is very important here, that where we are actually, why this subject is very important. Now robotic systems are already in operation for last say 30 years, 40 years. But these operations are basically either direct control or a short remote control kind of system, but not through any web-based systems, isn't it? So the concept of DGA was not there. It was basically the controller vis-a-vis the mechanical structure of the robot. So that kind of concept, but DGA concept was not there. Now, another important part here is, now when we are thinking of, we have to introduce a customized protocol. Now there is something which is very important. I will show in a next picture. But there is a concept called application layer in the communication hierarchy. This application layer is very important because that means most of these developments till date, whatever is available, say up to the year, I should say 2004-5, basically the last 20 years or 25 years, before those period, these developments were always in the application layer. That means whatever variations we used to make, this is the application layer, not disturbing the inner architecture of the network. But there are examples, there are cases that we can do even protocol level manifestation. That means beyond the application layer of concept. And this is where our challenges lie. And today, whatever discussions I will be making over these new protocols are mostly, rather all are based on these changes or the customization in the inner layer of our activity. So that's what actually is written in this slide, first para. So all these things, that is, in order to combat these bottlenecks, whatever already the web robotic systems are having, we have developed a good paradigm in case of controlling the single robot and as well as controlling a team of robot, but of course with a limited number of robots. In our example, we have used 4 robot system actually. So this we have attended through a robust software driven protocol and for a direct dedicated connection between the client and the robot. So of course, these are all wired communication as of now. So this communication is, there is a direct dedicated connection between the client and the robot. So when there is a robotic systems in operation and a client is defined, client or clients of course, we have to have a robust software driven protocol, and that is where our research actually helped. And also the server has been designed for offering simultaneous service. So the server is also very important. Of course, this progress in computer science and hardwares related to computer science activities also help this process basically. So server is to be designed or need to be designed for a robust level for offering simultaneous service to multiple clients. So this is very important actually. And client layer eventually involves user interface layer, which may be having any format, but should be with a GUI. So it is very important because as you cannot see the operation as of now, you are in a virtual medium, okay, between the robot, that is the serving medium, and the client, that is the user medium. You are having a virtual interface. So for this virtual interface, a GUI is very, very important, graphical user interface. So this was not very, you can say, significant. It was an auxiliary item in case of a normal operation, but it is a very important operation in case of a web-mediated robotic scenario. Okay, now let us go to some of the details. Now you see, till the time of development of this web-mediated robotics in a great venture, which is, as I was mentioning, taking place from the early 2000s, basically. Earlier, our protocol was TCP/IP. Okay, so this is the scene. TCP/IP based system is very robust, no doubt in it, and very initial developments of robotic protocols are with TCP/IP. So TCP/IP based data communication protocols are already available, no doubt in it, and this is now is to be tuned for a bidirectional communication link between a controller and a robotic system. So that is very important. So that bidirectionality of the TCP/IP protocol was first exploited to robotic systems, which are the you can say the first generation web-mediated robotics development. But in our work, what we did actually, software routines for double validation vis-a-vis checking of the data was implemented in order to ensure minimal error in the data transmission on both the sides. So this is the addition that we made over the TCP/IP. When we started on all these developments, I think something, if I remember correctly, something around in the year of say 2004 and 5, I think I started working on this web-mediated robotics, and the first developments of those period were basically with TCP/IP with some modulations actually. So basically these are all in the application layer, as I was mentioning in the previous slide. So what we did actually that time, basically we wanted the software routines for double validation check vis-a-vis the checking of the data. And those things were distinguished in the two paradigms. One is the control of remote robot and connection of remote robot over the web. So this is very important. These two attributes were the first thing. So even somebody wants to start a new research in the web robotics, he or she must do these two tasks. One is the control of remote robot. First, they have to control the remote robot using that basic TCP/IP protocol in a LAN or WAN. And then number two is the connection of remote robot over the web. So first, once you can establish your protocol, whatever protocol you are writing either from scratch or in the application layer format, you have to first deal with the control of the remote robot, and then you have to go to the controlling the same or the connection of the remote robot over the web. Now, once we are satisfied or once we are having the pulse of that or a grip over it, what interesting thing came to my mind, then I'm telling my own story actually. I was thinking that there is a concept of reliability, because robotic systems have to be very reliable. Unlike the case of normal mechatronic system or a purely mechanical gadget, robotic gadgets has to be very reliable, very precise, because it has to do 24/7 tasks and in a routine manner and in a very punctual and accurate manner, so to say. So the reliability is very important. So protocols in the transport layer are basically classified by the amount of reliability they offer. So that means when we are writing a protocol in the transport layer, then that means the transport layer means the actual, you can say the flesh of the medium that is actually going in the bidirectional communication. So over the skin is the application layer and the flesh is the transport layer, and we will see the paradigms which is known as the backbone of the systems. I think that figure will come very shortly. So this thing came into our mind that protocols in the transport layer, so they should be basically classified by the amount of reliability they can offer. So that means if we can have a tuning over the reliability of the transmission, then we can have much more advantage in this process. And that is our, you can say, the initiation of our new development, which is a very prestigious development of our, lot of papers were there and patent also, variable reliability data flow protocol, or the VRDB. So this is our own research. Will do. That means we can have some new protocol with a variable reliability parameter. We'll see to it in detail. Yeah. So this picture, I will dwell a little bit time on that because this is very conceptually a fundamental principle, a fundamental picture, I should say. So you see what is happening. Now, web robotics is essentially some kind of thing that is important in the transport layer. So transport layer is you can say that second from the top, over and above the skin is there, which is the application layer. So application layer, as I was mentioning, is nothing but the GUI come very cosmetic changes and all those things. Now in the transport layer, basic things were there which were ruling till the time web robotic protocols came to the picture are nothing but TCP and UDP, where a TCP is, you can say, fully reliable and UDP is the least reliable. Then below that we are having the data link layer, which is some kind of a bone of the structure, and physical layer. Physical layer means it is basically the actual computer's hardware part of it. So physical layer, of course, we are not supposed to change anything. And then data link layer, sometimes there are some changes possible, but mainly the transport layer, that is actually the area where we can play around. So this is very, very fundamental knowledge, fundamental concept for any researcher who is interested to do research in the web robotics, that you have to think of the modulation in the transport layer. And we have two guidelines, one is TCP, another is UDP, and you have to play around in between these two. So this conceptual schematics is very, very important, and the layers concept and all those things. So this is what actually happened in our cases also. For any physical mechatronic device and control of this device and the connection to the World Wide Web were done through this changeover. And of course the DGA, as I was mentioning in the second slide, the distributed generic architecture is very important. So just to give you an basic information, all these experiments actually on this web robotics kind of thing were started in the last decade, basically in 1998, as I was mentioning. So it is early 2000 in our country or whatever. So in 1998, the first thing happened in the University of Western Australia, and those were found by and large satisfactory. So that was the first initiation of web robotic type of system. And of course, that control was made, particularly in this 1998 case study, it was made in the local area network only, and then some kind of a detailing in the cases. So we'll go that. So, but then, you can say that developments, whatever happened those time, in the case of in the 1998 and early 2000 to some extent, basically they were basically the variations in the application layer of the communication hierarchy, but not at visualizing innovation ideation at the protocol level. So the protocol level changes were not that way entertained that time, because that everything matters. Research cannot go one-sided. So it needs hardware interfacing, it needs development of the microcontroller, chip, computer system, everything matters a lot. So considering the developments that happened during that time, it was considered satisfactory if we can change something in the application layer itself. So that was the kind of area kind of era actually where we were domain. So user interactive communication theology ensues the concept of emerging tools of internet-based remote transparency has attained commendable potential in recent past. But after that, we have attained several potentials, and these are all in user interactive communication theology, and those are in the transport layer. So yeah, I think I will go to the some key structure. Now, another important format in during that thing is that the development must start with very basic communication, basically the text-based format. So text-based formats were the first thing that was attempted during those days, and it was found to be quite satisfactory. Now, in our case, what we have done actually, that is very important. So we devised novel technique whereby the web server is bypassed and the web enability is ensured by means of peer-to-peer socket communication between the client and the host in situ. So that was the first research we did very successfully around 2004, 5, 6 also. So that was a technique was devised where the web server is bypassed. That means we didn't have any problem with the basic web server because you know that most of our communications in atomic energy are to be done in a very secure way, in a very secure channel actually. So we were thinking that how to do that thing, and it is a peer-to-peer socket communication concept was made during that time. Okay, so I will go to the next details. Yeah, so this is a very interesting, and I think you will appreciate this is basically a chronological progress of web robotics. So web robotics, as you can see, that first level of remote actuation, not web actually, but remote actuation was started in the 1940s. So, just after the, Second World War time, and after the little invention of the atomic energy systems actually, the remote concept, remote actuation started. Early 1950s is the domain of teleoperation, which is a vast concept and it is going up to 1990. So teleoperation is a very successful technology all over the world, and it started in France during the post-World War time. And then India also got its basic technology transferred from France during that time in the late 1950s during Dr. Bhaba's time. And afterwards, we were self-reliant and we had to be that way because there were a lot of sanctions because of our Pokhran 1 test and all. So this teleoperation technology is a very successful technology all over the world, including India. That's what I wanted to make. Then early 90s, I should say, that telepresence experiments started brimming in. So that is the first, you can say, the web robotics kind of thing is the telepresence. Then the VR or the virtual reality comes in the picture in the early 2000s, internet telerobotics, network robotics, etc. So it is going on. Of course, now we are in 2020. So in the 2020, things are in March, as you know that web-based even remote surgery is also being performed. So that is the kind of a spectrum where we are actually moving in. Yeah. So as I outlined in the slide, one important parameter of web-mediated robotics is MIMO or multiple input, multiple output system and its characterization. So this is very, very important actually. Now, because as we are controlling this robot through the web, we must have a concept of input and output concept. Now, what are the inputs possible? So this diagram is significant. Let me explain it in detail. Now, there are three kinds of input possible in web-mediated robotics. One is PC-based, that is either it can be intranet or internet. Telephone server, which is PSTN or APBAX, and the mobile phone server, which is web kind of a device, wireless application protocol based device. So these are the three inputs that we can have. PC based, of course, it is the most common and rugged, but we can have telephony based control of a robot. We can have a mobile app-based control of a robot also these days. And that is the reason the system, which is the black box of this web robotics controller, will have three servers, either any of the servers or all of the servers or any two or whatever, depending upon the input. One is the web server, another is the telephony server, another is the web server, and they will be having a direct link with the database. See, in the outline slide, I have stressed upon the database because see, in all these kind of things, you need to have a sound database of actuations, activity log of the robots, etc., etc. And there is something called business rule. That means, something called, that rule governed by the users is there is some speciality. So that will constitute your web-based robotic system. And in the output, we can have through PC, computer-based output you can have. We can have the output to telephone or the cell phone or the fax machine, printer, soft copy, scanner, or scannable copy, or the email. So these are the things by which we can have the output. So one has to be very careful about designing a web robotic system in this MIMO format, because that will give the things as a full glare. Okay, so with this basic diagram, we can say there are three input media types or the server type. One is the web server for internet-based clients, telephony server for clients hooked up by the telephony communication, and the web server for the wireless clients. So these are the things, because see, protocol and all these development should be with this kind of a server-based concept. So web server, telephony server, and the web server. And of course, there are correspondingly there are three different interfaces also according to the three servers. One is the website, because when it is a web-based server, there must be a website for operation. When a remote robot is being operated, you must have a dedicated website for that with a GUI system. The telephone user interface of the TUI for the telephony-based clients, and the WML pages for the as the GUI for the web client. So these are very fundamental concepts actually. So you should have a website and the GUI according to the need of the web server. You have a TUI or the telephone user interface with the GUI possibly to some extent. Of course, in the TUI there is no need of GUI as well, and WML pages are the GUI for the web clients. And of course, mostly all these servers use the same database. This is very, very important for the authentication of users. That one user can be from, website-based system. The same user can be from the web system. The same can be in the TUI system. So authentication is very important because they must share the same database. And these are driven by the ASCII text files or the DLL register. So these are very standard way of, controlling the system. So those things would be there. And the system is receptive only to the data and not to the inner protocol of the input medium through which the data is being transferred. So that is also very important. This MIMO system, one fundamental paradigm of a MIMO system is it should be based on the data. It should be receptive only on the data, not the protocol by which the data is being transferred to the system. So now from the user side, what is happening? User can be a PC-based user, either intranet or internet-based system. If user can be a landline telephony-based system user, and user can be of a mobile telephony-based system also, accordingly. And web server can be IIS or PWS, so many details are possible. So this is the full gamut of a MIMO concept. Okay, so with this basic knowledge in our background, let us go to the development that was made by me and my research group. Now, first is the graphical schematics for the socket type virtual server system design. So first what we did is as we were mentioning, the bypassing the web server concept and peer-to-peer communication establishment system. So this is the way how we started. So client and socket based communication, which is basically the virtual server-based system design. And once we have, conceptualized the system in the bottom top diagram, as it is mentioned, that means web page, program, socket, etc. So basically, it is a kind of a key. Socket is nothing but a authorization key, no? and we have translated the system to the web page, and you see the bottom left this thing is a web page actually, and bottom right is what we did actually. That is type of a control of this kind of a small tabletop robo. Okay, so that was our first experiment, that this kind of a small robo. So we didn't start with a very big thing because we wanted to prove the concept. So this robo is another one of my first indigenous hardware actually, and this robo having a two joint system, a Revolut type two joint system with a gripper, and this was controlled through this kind of a socket type peer-to-peer client server communication. So all these studies were made in-house, and we have a very successful log of a report. Now, once we are successful in this peer-to-peer communication, we transported the concept to the World Wide Web. That means now we wanted to test it through the website, through the full web-based control using the web server. So earlier it was basically our local loop, or you can say that to some extent intranet, by bypassing the web server, and with a PWS web page, as I was showing in the last slide. Now this we are moving to the World Wide Web concepts, and basically the procedural logistics for this type of control is we have to have some kind of a controller computer, server computer, and the device robot computer basically. So we have a server computer in between. That means what is happening? Earlier it was a direct socket, socket kind of a key to key concept. Now that is the intermediate layer has come in, which is a server computer actually. And of course, there are applications also changed. Now, if you just look at this block diagrammatic view or the text that is written in this slide bottomwards, so we have a dedicated website like www.xyz.com. That means this xyz.com is basically our dedicated web page, or the not web page, I should say website actually. And this website has to be invoked for a controlling operation. And the tool that was used during those period, as I was mentioning, 2005-06, it was VJ++, Visual Java. So Visual Java, ASP, those were the tool at that time, and those were used with SQL and all those things. So this is the kind of a concept that was used, and what we actually was parameterized is that angular motion of joints of an articulated robot or the output signal from the sensory device. So these are the two programs that we were attempting at that time. One is the joint angular motion of an articulated robot. The robot was already shown to you, or the output signal from a sensory device. I will also show our own indigenously developed robotic sensors where output signals were also controlled. So this is the paradigm where we moved from this direct socket-to-socket communication to a World Wide Web-based communication structure with a dedicated website for that. Let us see the details further. Yeah, so this is a very interesting figure and a very successful chapter of our development. So activation schema for the physical device over the web. So you see that physical device, we have taken the full robo. Okay, the similar to that what we have shown in the picture, the same robo in fact, and we have used the same program and the same robo with having a gripper now. So earlier this gripper was not actually controlled. So basically now this gripper is in control. That means here our main attention is the gripper, not to the joint. That means finally we want to do some task. That means this is the controlling of the physical device over the web to do some task. Now what are the tasks? You see that bottom photograph, the small gripper, and this is another interesting story of our research actually. This is a very, very small gripper. In fact, to tell you very openly, this dimension is really shocking. It is 50 mm only, 50 mm length, 35 mm width, and 15 mm breadth. So this tiny gripper is holding a marker pen, as you can see, and also there are other two grippers which are equally small gripper, a little larger than that one, mini one, but this is also equally. So this gripper technology or the gripper performance came in the picture in this kind of a physical actuation over the World Wide Web. Yeah, so another interesting point that also was tried during that time by my student group is basically a small robo, a small kind of a Lego robot, basically to study the how the motor functions. Okay, so this is also very important activation actually. Now, in the case of this remote robot actuations, we have three stages, basically stage 1, stage 2, and stage 3. And these are through all, as well as mentioned, that customized website. Now, in the stage 1 is applet activation. That means you have to activate the applet for that. And all these GUI and the programs have been developed totally in-house, totally indigenous development. So first stage is applet activation, second stage is GUI activation, and third stage is the actual, actuation of the motor. So because the one fundamental aspects of robotic systems actuation is the controlling and actuation of the servo motors for that. Okay. So because that is the fundamental thing. If you have to activate some kind of a robotic system, you must have a actuation of a motor system also. So the first stage is the applet activation, second stage is the GUI activation, and third stage is the actually the remote robot activation. Okay. So we have done the things by these three methodologies. And there are some details. So that means how actually the backbone of the program went. Okay. Basically, this is the testing through software simulation, and this is the display So we use the basic TCP/IP architecture, and then we build up our own robotic system for that. Okay. And there are two important things actually that must be told at this level, because this is very important from R&D point of view. One is the simulated environment of a typical physical device, and another is the syntactic hardware of the SAS system. That means these two program modules have been verified and tested exclusively through these two. One is the simulated environment, another is the syntactic hardware of the SAS system. And these are the features and all those things. Okay. Yeah, now we move on to the our next important paradigm, which is the VRDP, that is a variable reliability concept in actuation control. So this is very important because this is the first attempt of ours in the protocol level. The earlier thing was basically in the application layer. That means we didn't disturb the TCP/IP. As you can probably look at the GUI and the screenshots that I have given, you are observing the TCP/IP number, port number, and all that. That means we didn't disturb the TCP/IP. Our main interest to have the socket communications through solo, through remote level, and through web level also, and the gripper actuations for that, and we were successful in that. Now we move to something in the protocol level, that means basically in the application layer, in the transport layer. And in the transport layer, the first attempt was our own development of VRDP. Now, what is happening? In case of VRDP, what we observe that TCP, which is the transmission control protocol, and the UDP, whether the user datagram protocol, they have been used hitherto. There is no alternative for that. It was so rugged, so robotized, so ruggedized that there is no, you can say second thought to that. But what fundamentally it was observed, while TCP assures full reliability, okay, TCP gives full reliability in bidirectional data communication, UDP does not seek any acknowledgement, thereby making the entire system unreliable. So this is the two extreme cases. Now TCP uses full reliability. There is absolutely no problem. You can be safe enough for your data communication, and UDP doesn't even seek for an acknowledgement. Forget about the reliability that can be offered. Then why we will be using UDP? Issue is the communication time and avoidance of the network congestion. When we have to do the thing faster, UDP is the solution, or maybe UDP is the preferred choice. But when we have to do with full reliability TCP, now the thought that came into my mind that why can't we have an in-between? Let us think of in-between. So I sandwiched my VRDP concept with the association logistics in between this TCP and UDP. So that's the very basic fundamental concepts here actually. Basically, I am not going to the details of that. I am only going to some of the important statements. Like here, I should mention that VRDP can be entrusted to achieve the ultimate goal, namely the reliable transmission in optimum time. So that's what engineering practice counts. That means you have to have some kind of reliability, some level of reliability, but we have to also, we cannot forget the time for transmission. That means reliable transmission in optimal time barring minimum loss of information. So this is the motto of VRDP and this is the background of VRDP. Okay. And of course, we have to have some benefits of TCP, some benefits of UDP also. So let us see how we can go ahead with that. Yeah. So I will probably dwell a little more on this diagrammatic designs. So how the design was conceptualized. So design overview of VRDP. Now you see the first top figure is that between TCP and UDP, I have punched out 5 levels of VRDP with a decreasing level of reliability from VRDP 1 to VRDP 5. Okay. That means I am punching out some new transport protocols, new protocols in the transport layer. And say in my case, we have developed it in the 5 steps of VRDP, VRDP 1 to VRDP 5 with a decreasing level of reliability. So this is the concept of multi-slotted reliability levels of VRDP. So this is one of the fundamental R&D that went actually, concept of multi-slotted reliability levels of VRDP. And with that concept, the second figure is coming in the picture, which is connection specific metric of VRDP. Now you see, we are in a World Wide Web. There is a transport layer, and all this research is going on in the transport layer that is already mentioned. So VRDP 5 and VRDP 1. Okay. So VRDP 1 is basically connection oriented and VRDP 5 is connectionless. Connectionless means with a less reliability. So that kind of a concept actually. And this is the backend platform is like this. Of course, it's a Linux. So because you know that most robust and most open level platform is the Linux. So Linux network protocol stack is something like that. It means we have the BSD socket, that INET socket, then TCP, VRDP 1 to 5, UDP, internet protocol layer, that IP layer, and then the physical hardware, physical hardware connection like Ethernet, PPP, sleep, etc. And beyond the BSD socket is the user kernel, so application layer. So this is the stack of the platform that what was developed. And the Linux kernel customization was also made, and several applications and programming details were made. So I am not going to that detail, but that is more of hardware actually. So basically you can have these 3 kernels. One is the TCP kernel, B is the VRDP kernels, rather VRDP 1 to 5, and C is the UDP. So this is the kind of a layer and hardware level concept and all. Now what is happening here is that there are two sockets. One is the socket VRDP and that is being invoked actually. The second figure is also very important, which is basically the VRDP header options actually. Now in the VRDP header options, there are 2 things. One is the VRDP permit A and dummy segment B. So that means there is a permit level concept coming in, and then we are putting a dummy segment in front of that particular stack actually. Yeah. So with a starting sequence number SSN down to a stop bit. So first in the starting sequence number and stop bit, and then we have the packet. So that is the thing, that kind of a reliability we are putting in the picture. And once this particular architecture is frozen for VRDP, we went on the programming language developments for that, like the development of the programming for that. So the programming modules are 2 types of modules. One is the paradigm for modified packet receiving with respect to TCP, and algorithmic semantics of the retransmission mechanism. So there are 2 important aspects. One is the modified packet receiving. Now how the data packet will be received in that format of VRDP, that is the program for that. Another is the retransmission. Because see, what happens in robotics is that we cannot afford to have a failure. Okay, it's not something like in a normal network communication that something you are transmitting, some data packet is lost, something maybe little bit of accepted or managed. You cannot afford to do that. If a gripper fails to do the job, the performance is 0. That means it is failed in its operation. So we have to ensure that there should be a procedure for retransmission. I mean, at least if some data packet is lost in the retransmission module, we will be attempting to give the data packet. So even a single data packet must not be missed or lost, because the whole operation will suffer by that time. So that is the fundamental thing that is to be understood in a normal network communication vis-a-vis a robotic network or the web mediated robotics concept. Okay. So packet receiving matrix of VRDP is also outlined in this block diagram, and so there are various procedural things actually. So I am not going to the detail, but a fundamental thing is, unlike TCP, here in the VRDP we implement a modified version of the algorithm for the receipt of data packets, and this modified version is shown in this block diagram, basically a flowchart basically, and the nucleus of the algorithm lies with the metric called receive queue. So that is the concept of receive queue. So in the receipt area, there is a queue concept, and that is the most important part of this thing. And in the retransmission also, the similar logic on the legends, procedure have been used. And in the case of VRDP, we have used a dummy segment option to convey the starting and ending sequence numbers of a segment being retransmitted via the VRDP header option. Okay, so that's the fundamental changes of VRDP that was not there earlier in case of our TCP or UDP. So the retransmission algorithm of VRDP was designed with a basic understanding, of course, whether it is truly needed the data packet to be transmitted once more. So that is also very important. That means unless and until we need it for the retransmission, we should not do it, kind of thing. So that is the way the dummy segment option comes in the picture. Yeah. So these are some of our experiments that was done with VRDP. And of course, this experimentation syntax was also based on two paradigms. So it is basically the first version of VRDP version 1.0. We carried out exhaustive lab-based experimentation with forward communication pathway, and but those were tried mostly with the LAN environment, and VRDP version 2.0 was little more advanced with some more programming sequences, and there we attempted for three objectives. One is the evaluation of performance in reverse communication for non-text data packets as input. So this is also very important. That was not there in the VRDP first. Basically, we tested for forward communication and its acknowledgement sequence, but reverse communication for non-text based data, that means some kind of a image data or animation data, because in robotics we have to use everything. We need text, we need image, we need animation. So you have to fundamentally play around with these three. So one has to understand in web mediated robotics the basic block diagrams are these three. That means text also you have to handle image, you have to handle animation or the videos or the movie or whatever files. Okay, so the protocols are different. Now, in the first version of VRDP, that is VRDP v1.0, we didn't attempt for all those, because our main main objective at that time was to have a robust protocol developed in the transport layer without kind of interfering with TCP and UDP, and having a self-reliant protocol developed, and that was tested also. But in VRDP 2.0, we have progressed a little bit far, okay, reverse communication, and also the animation of the syntax. So this was the representative non-text files used for the testing of VRDP 2.0 and SRTP. There was another small, you can say that protocol developed called SRTP, which is Systematic Reliability Transport Protocol, but it is more or less an offshoot of VRDP, so I will be not going to the details of SRTP. One is the pure graphics file, another is a file with scan text. So the first graphics file is a pure graphic with different colors, okay, and second is the color with text written. So how this type of files are being tackled by the VRDP, okay, so different colors, excluding the white colors, of course. So these are the experiment we did. Now, once we are successful in establishing this experiment, the final experiment was done like this. which is a test setup using a robotic sensor system. So this is a very, very important story of our success, is that this robotic sensor, of course, is another developmental history of mine. That is another indigenous development of a robotic, small robotic sensors. And this establish a reverse communication. That means from the sensor, we are getting the data, okay, in the form of sensor data. So the sensor data is actually being transferred to the client computer, okay, where the robotic sensor is in physical distance apart in some other place, geographically apart also possible. So that's kind of things. And this robotic sensor is a very interesting hardware actually. I think I am having the photo little more elaborated view on that. So a lot of experiments we did with this robotic sensors hardware during the year 2007-8 basically, along with testing for VRDP also. So this is basically developed as a tactile sensory matrix with very miniaturized struts as the sensor elements, and these elementary sensor cells are located in 3x4 rectangular array over the metallic base. So these are the things. So it itself is a very interesting hardware, and what essentially it calls for, it has got lot of sensor data in real time. That means at every time instant we are having say 3 fourths are 12, and each will having 2 strain gauge basically, so 24 elements, okay. So total 24 sensory cells were excited in any time t equal to ti, and that 24 as a data packet or whatever, it is coming to the client computer system. So this is itself is a very great task for a reverse communication system. So I think that is a very successful story of ours, and VRDP 2.0 always does a reliability check and a cross checking in a proactive way. So that kind of a thing. But of course we are limited to text file because we only wanted to have a sensory information feedback. That means how the sensor, see, when the sensor is excited by external stimulus or by external loading, the sensory the elements of the sensor will give the signal. So these signals, which is basically 3x4 into 2, that means sorry, plus into 2, yeah, that is 24, and these 24 text cells are giving the data. Okay. Yeah, so this is a little more photographic elaborated view of this, and you can see the struts, very miniaturized struts made of with very fine CNC manufacturing process those days. Of course, these days we can even think of rapid prototyping for this, but that time the rapid prototyping was not that popular. Anyway, so we did it through CNC system, and we have our own indigenous instrumentation for this. And as you can see, we are having there is a rubber pad also, and there are R cells are basically the resistive cells. That means there are strain gauges affixed to that, and wires are getting out of that. So this kind of a hardware was made, and that was very successfully tested for VRDP. And how it goes, this is just to give you some interesting features about this sensor, because unless and until one is aware of the full hardware of the sensor, the usability of the sensors and its information flow out of the sensors will also be in a kind of a jeopardized form. So I felt that it is very important, because this is also a very indigenous development of ours, 100% indigenous technology and customized design, and of course indigenous and original original concept actually. So what is happening here, basically it is used for a sleep sensor. Now the sensor which was actually used for VRDP testing, VRDP v2.0 testing, was a little larger size. Afterwards we miniaturized the thing, and the miniaturized version was actually used for a gripper sensor actually, so that it can be fitted at the jaws of the gripper, just like our human, our skin, skin of our hand. By touching we can understand whether the object is going out of my hand, whether it is going out of my range. So that is known as a sleep sensing or the sleep sensor. The fundamental principle that was behind this development was matrix based design. In fact, this concept is very universal. See, not only the matrix based concept is useful for a mechanical hardware, but it also used for a you can say that sensor information processing via web, in the web mediated control also. As you can see that since it is having multiple starts and multiple sensors, there are maximum number of text cells. the sensory element or taxel we call it, and these informations are getting fed to the remote client or multiple clients. If the system is invoked via MIMO, there can be multiple clients as well. Okay, so this is the thing. Now, how this information or the sensory signal is going or the excitation is going. Now, you see on the rubber pad, there are several serrations which is known as B. So this A and B, now there are something like a small pin, which this small pin is pin index number E. So that is affixed at the backside of this rubber plate. So it means when there is an external excitation on the serrations B by an object, the projection pins are getting deflected and they will create some kind of a small vibration, small sensation in the struts, and that will have some kind of a slip force kind of thing generated. So this is the very concept. Of course, this forum is not for going to that detail, but just for example, I am giving the things. And this is a several mode of transmission. And there are also data fusion technology involved and all those things. So I am not going to that details right now, but there is a information. So this external force FT basic we call it, that FT basic is getting transferred to FT strut, and this strut, now phase 1, 2, 3, 4, these Roman numbers are basically the stages or the phases. So finally it is going to the strain gauges in the phase 4. So that is the force transmission inside the sensor cell is being duplicated. So this is important. And there are formulations actually, all mathematical formulations, how this object is getting shaped and all. So when the object is placed over the sensory cells, it looks like this kind of a variation of vectorial map. So there is a sleep X, sleep Y and all those things. So this I am skipping right now because there are already mentioned. So basically from stage 1 to stage 4, there are several force transmissions, and these force transmissions are important. Now, one interesting pattern of this thing at different stages of this transformation, perhaps in the latter part of somebody's development in web robotics, one can even capture all the stage, intra-stage forcing functions also. Yeah. So with the success of our, you can say that VRDP version 2.0 to be specific with the robotic sensor systems, we moved on to another important characterization of these systems for master slave manipulator MSM through the actuation of servomotor system. So what is happening, as I was mentioning in the very initial slide, that for all robotic systems you must have a very fine control over its servomotor for operation. And once the servomotor is in control, you can have a kind of a much better hand over the whole system. So these master slave manipulators are being controlled through this kind of a you can say that web enabled kind of system characterization actually. Now what is happening here, and by the way, these master slave manipulators are of two types. One is master slave serial manipulator MSSM, another is master slave parallel manipulator MSPM. So I will use these words in the next few slides actually. Now what is happening? There are 3 input data received from the respective 3 joint motors of the master manipulator. So if the master manipulator is having 3 joints, now as I have shown you in our basic research of peer-to-peer communication, socket-based communication, or even in VRDP also, we have learned how to control a motor. Okay, we have seen that thing actually. Now, if I have a series of kind of a input from the 3 joint motors of the master manipulator, that means A1, A2, A3 here in the block diagram, and finally E is the slave side servo motor. That means one is the master robot, another is the slave robot, which is basically the fundamental principles of teleoperation or the remote master slave based operations. So the slave robot is to be controlled by the master manipulator through the World Wide Web or through the system. Now first we have developed the system for a LAN, that means for a wired communication, to have a full-fledged idea. So that means we have used actually various servers for that. Is the point number index as B, then C is the computer for the processing the input data stream, D is the national instruments hardware including chassis, terminal block and signal conditioning card. So I am giving a stress on D because for all this kind of a wired communication, and maybe finally for web-based communication also, hardware support is also very important. And one of the greatest support that came to my research, to my group, is through National Instruments based products. So these products are very rugged, very useful products for robotic systems. So I have always used this, and I am a big supporter of NI instrumentation. So with this NI instrumentation, what we actually did, that how the output of this motor at E, that is a slave side servo motor, is rotating. So output shaft is basically rotating. So number F, item number F is rotating. So that is the picturization for that. And with that, actually, with that success of motor rotation, we have actually have a very interesting success in the four of our products. In fact, these four products have been shown here with the motors of this kind. The motor, that blue one, is shown in the central part. So this motor is being interfaced to four products of mine. Two are the miniaturized grippers, as you can see the bottom figure, and another bottom figure, which is my most recent development, just 1 month old baby, and that is a very interesting development of sensor instrumented miniaturized robotic gripper, and we have used the motor. So this motor, and also the two other products, which is one parallel jaw gripper, another is the rolling segment of another interesting hardware actually. So that the success stories were motor communication through, you can say that remote activation is possible. We have achieved it. So yeah, two basic trials on the remote actuation on servo motor are very vital. That will be basically with NI systems, and LabVIEW is another compatible software for that actually. And there are several instrumentation cards and all. So this is basically the principle of operation for the master slave kind of manipulator. So I am not going to this detail because you can read if you are interested. So essentially this hardware has a big role, and also the LabVIEW software, because this all the full programming has to be made in the LabVIEW through a kind of a panel and control diagram. So it is very nice software actually. So if you have used it, fine. Otherwise, I will always recommend all robotics researchers to use the LabVIEW software actually. Yeah, so with that success actually, we have always also moved to another concept of master slave parallel manipulator control through web mediated control. So what we have done here actually, so we have extended the system, whatever has been tested with the sensor systems, and with sensor system basically we moved on to a parallel manipulator, basically the slave system interfaced with the C, and the slave system is nothing but the sensors there. So the parallel manipulator, which is shown in the upper figure, and it has got sensors, and which sensors are nothing but the sensor that we have used. So that kind of, so little more extension of whatever we did earlier for the slave servo motor control. So that we have extended to this also. Okay, and there is a concept of synthetic forcing. So this synthetic forcing means the sensor is generating the force, and that force is used for again controlling the legs of the parallel manipulator. So those are the hardware details for that. Okay, so now we'll move to the web control of team robots. So these are all for the solo robot. That means whether when the robot is in single, whether it is a perfectly solo robot or the master slave or whatever. Basically, it's a single robot that we are controlling. Now, in case we have to control a team of robots, that means there are multiple robots, then what will be our protocol and what will be our control strategy, or how the central server will be augmented to that. Now, I am reading out the first sentence. Unlike the case of solo robot, the team robots need much more sophistication while getting control through the web. The foremost attribute is the coordination between the member robots and the central server. So this is very, very important. So coordination between the member robots and central server. Now you can see that in case of the earlier protocols, whether it is socket to socket control protocol or our VRDP, version 1 and version 2, etc., whatever has been developed. Now, for this type of protocol, there is a new, you can say, stigma is coming, that is coordination between the member robots. Earlier, that particular paradigm was not there. It was only between the coordination between the robot and the central server. So this is the difference actually. Okay. Now, so this need for the research in developing the new protocol for the team robots has been conceptualized by me, and this was fragmented into three parts. So team robots protocols are fragmented into three parts. One is for the synchronized animation, then second is for asynchronous real-time imaging and animation, and third is coordinated control in switching between the options. Okay, so these three are the fundamental protocols that were used by me. One is for synchronized animation, then asynchronous real-time imaging and animation protocol, and coordination between the control in switching the option. This is very important, and we have gone through the details, so that I will show now. Yeah, so first thing is the synchronized animation transport protocol, which is the, we call it SATP. So synchronized animation transport protocol, or the SATP. So what is happening in the case of SATP is like this. That means user need to view multiple files from the same location belonging to the same set of devices of the robot. That means this is the concept actually, that user need to view multiple files from the same location belonging to the same set of devices. That means if there are same set of devices, some 4 devices, like whatever is given in the right hand side, small insert photographs. So there are 4 robots of near similar structure, and these 4 robots are generating the databases, 4 databases which in the remote servers. Okay, and in fact one server is being shared by the 2 robots also. So there are 3 remote servers, and there are 4 clients actually on the user side. Okay, so the user will need to log on to the directly to the remote server, and then he or she should have the make individual requests separately for each of the files, and there will be a central database. We have provided a central database wherein the user can log on and choose a particular robotic site to send commands to or receive files from. Okay, so this is the basic paradigm of the SATP. And SATP is also, of course, developed under Linux, and front end was developed through PHP. So as and when the progress was developed, as you can see from VJ++ to PHP, we have moved that time. That means when the SATP was developed. So those things are not very important. Like, you know, if SATP has to rewritten in today's language, one new language may come up. That is not an issue. Issue is that whether the fundamental logics are being used or the remaining the same. So this is the coding structure and all, and how the SATP is to be used. Okay, after login, when the authentication will come, then the command sending request, then if the file to be downloaded synchronously, then what is the things to be done, etc. And these are some of the snapshots of the GUI developed for SATP. The basic idea is there not to probably read the snapshots directly, but so is it made user friendly. So the user friendliness is very important, because as and when we are moving towards much more sophistication, the GUI has a big role to play, and GUI will not only perform the basic operation but also perform the you can say that basic semantics of that. Okay, so in a similar fashion of login, passwording, downloading, all those things are involved. Now, in the design architecture of the header concept was used, and several tags and flags were used. So these are very much part of the developmental work, and so those developments were actually being used, and like that it has been conceptualized. Yeah, so here we are actually using with 4 robots. So that was the testing that was done for this SATP. So these 4 small bots were actually used, and their movement was studied, whether they can really do the synchronizing animation they are giving. Okay, so if there is an operation that is to be done, so the example is something like that. That means that you are having a team robot which is working, okay, and you want to download the or observe their performance in totality, then you need this kind of a protocol. So this programming is again through the in the first module socket programming was used to the clean the client. In the second module is the program into the waste kernel, and you see that how this synchronization was made. That means if we give command to one, it is getting forwarded to all four, and all fours are performing the same. Okay, so that's the very interesting part. That means your four robots are at different locations, maybe in the LAN only, not very geographically different locations, of course. So then based on the commands that it was given, it is performing with a more synchronized option. So this is a very important figure. Okay. Now in SATP there are phases actually. The development of this SATP was in several phases. So like phase 1, phase 2, phase 3, etc. So in the phase 1, we have a basic model of a client server program by creating the socket. In the phase 2, the server could send a group of files to the clients. In the phase 3, the synchronization effect comes in. That means first two phases are basically the program for the client server, and the third is basically the invoking of the synchronization part of the transmission. And in the fourth phase, basically the buffering of the data received from the server, and phase 5 is basically the dynamic, making the HTML page dynamically whenever the new data is arrived in the buffer file. So that's how the different phases are being augmented here. Well, now we'll move to the another interesting protocol, which is basically switching between the protocols. If you just remember in the index slide, I have mentioned the switching between the protocols for a coordinated control. That means when we have to have a coordinated control, we will be able to have our system with a switching. So the protocol that was developed is called real-time switching protocol, RTSP. Now in RTSP, or the real-time switching protocol, we have used only when real-time video is to be transmitted, and then only the RTSP was used. That means if in case of real-time transmission of video of a robotic operation or the team robotic operation, we have used the RTSP. So RTSP also having say 3 clients and the network and the RTSP server, etc., etc., etc. So it's a similar type of concept, but basically it is for the real-time switching concept. The functional layouts are like this. So we have a main server, then the video processor, because as you are knowing, this is meant for the video processing, then video server, HTTP server, etc., etc. So very good. And data flow is also like client to data flow. Now here, the interesting part of RTSP, this was tested with another interesting hardware of my development, which is known as CURL. CURL, which is Compliant Universal Robotic Leash. Now this is, let me explain it because this is another interesting hardware that was tested for RTSP, is that this particular hardware is just like a very miniaturized biorobot, which is having 3 segments. One is called the crawling segment, another is the rolling segment, another is the gripper segment. The rolling and gripper is also shown in the left hand side bottom figure also. You can see the photographic view. So this is how the actual hardware looks like, and this is a very interesting structure, and this structure is actually meant for pipe inspection. So and this is actually tested for RTSP, because see here what is happening, sometimes we have to switch between the video transmission, because in the pipe inspection one must have a video transmission, and it has a camera also inbuilt. So this, with the camera inbuilt, this fellow can also take its own images inside the conduit. And there are YouTube videos in the last at the end of my lecture, I will give you the link of those YouTube videos. You can see how the performance is being governed. So this is a perfect example of using the protocol of RTSP, and that was tested for that. Now the object level design, as it is very important for any new protocol, we have a RTSP design also. So in the application level and the kernel level. So mainly in the application level, these are the things. So basically, because it is very difficult if you have to do something in the transport layer. or the kernel level. So this particular RTSP is mainly in the application level, where you have the video processor, server, library, and image property, etc. So all those things are there. And the kernel level, there is not much of changes being used actually. But what is happening actually, these uh, things are uh, much elaborated in the application layer itself, okay, because of the structure, because of the robot that is being controlled. Now, with the development of the switching concept between in the RTSP development, we move to two important, you can say, sister protocols. One is called ATP, Animation Transfer Protocol. Another is ITP, Image Transfer Protocol. Okay. So, in the image transfer protocol, the transmission syntax is given here, that how the packet number and the PDU offset segment number, everything is given, and how it is fitted in the HTTP, FTP, and all those things. So operational block diagram of ITP. Similarly, in the case of animation transfer, also the protocol. So these are the groups of things that we are played for the team robots. Okay, now we'll move to another interesting feature of web robotics called database management. So this is a very kind of a important tool, I should say, and its importance is becoming very great in the recent past and the near future also. It will be very important. So it is a very important aspect of web-based control semantics. And what is very important in case of database management are, one is media independent. That means all these data, whatever we'll be getting, it should have a independent of the media through which it is being transmitted. It should not have any kind of a stigma attached to the media of transfer. That is, transmission of information should ideally be made in multiple modes, which are all equally likely to occur. Okay, and there should be a sufficiently large database also. So the large database is very important, and it should be able to do that thing. And there should be the development of new algorithms for searching process within that. That means the complexity of the situation, complexity of the database management will increase multifold when there is a sufficiently large database, and then amidst that sufficiently large database, you are searching for the new algorithm. So this is the two guiding paradigms for that. And there are interesting examples of our research in database management, and one such example is first is access of robotic systems to multiple inputs. If you can recall that gripper sensor photograph that the robotic skin sensor photograph that was given in the VRDP experiment. Now, over the time, we experimented and we made a miniaturized version of that, and this is the picture for that. That means we have used more number of taxels in this case actually, and there are not only the resistive cells, there are C cells or the capacitive cells. So number of sensors are increased multifold here in the with a miniaturized. This is known as our slip sensor design. It is the gripper sensor or the slip sensor. So this particular hardware was tested for database system, and we developed some kind of a attribute called slip sensor design system, where we can give the number of sensors input to be provided, and it will give the data that is to be transmitted with a very indigenously developed GUI and the management structure also. So those are the screenshots of these things. This database management can be with multiple databases also. So that is another very interesting research area, because see, these are the areas where people can do a lot of R&D afterwards also. Now, if there are multiple databases like I1, I2, say IN, okay, these are the multiple databases, and each one of that will be having, say, you can say that there are multiple databases. Sorry, I1, I2 are the inputs actually, number of input layers or the input servers basically, and the database is the DB1 to DBN. There are multiple databases, and we can have an output. Now, this kind of a system actually is a case of curl. So as I was just giving an example there in case of RTSP. Now this curl is now shown in a much more detailed view, and you can see this fellow
is constituted primarily by three segments. One is called the crawling segment, another the rolling segment, another gripper segment. So each and every part of that has got so many mechanical assemblies. That means it has a lot of a database. So that means you can have multiple databases. Like at least primarily you can have three databases, one for crawling segment, one for rolling segment, and third one is for the gripper segment. Now when in the crawling and rolling, as you can see, there are exploded assembly view. That means so many components are there, both in crawling and rolling. The rolling is having so many components along with the motor. Crawling is also having many components along with the motor. Now each one of these can be having again branching of databases depending upon the number of items. So this is a perfect example of that multiple database type of cases, and then how to access those things remotely. Multiple database case is having another good example in another very interesting hardware of mine, which is a specialized gripper for welding robot. Now this welding robot is having a good instrumentation. See this particular robot, which is the yellow one actually. The robot is having a specialized gripper developed. It is again A to Z is our development for the welding operation. So it has got a spring supported instrumented robotic gripper, WISROG we call it, and there are welding instrumentation, sensor instrumentation, and spring supported actuation of jaws, and it has got a dedicated gripper controller program and sensor instrument. So that means it has got a lot of multiple database. So one database is definitely from the spring support systems, which is the welding instrumentation. Another database is for the sensor instrumentation, and the third database is for the spring supported for the jaw. Okay, so this is the kind of, so welding instrumentation means basically the welding, transformer, welding gun, welding torch, speed, etc., etc. So these are the cases of there where we can have multiple databases. So right now the experiments are going on for database management of this particular gripper. Yeah, so remote access of multiple database can have another very exciting examples in flexible robotic system. Now this flexible robotic system is one of my very paid subject, and from 2007 and 8 I started working on this in a various form, and we have successfully developed two very successful prototypes of that, which is in a working prototype condition, and three you can say test hardware of that. Now this particular slide is showing there are two test hardware, the first top one and the bottom one, two test hardware of a serial chain 3-link flexible robotic system. So these are the cases where database management comes in the picture. Because why it is coming in the picture? Because this is a multi-link system. So there are 3 links means 3 databases. 2 joints means two databases. 1 gripper means 1 gripper databases. So these databases are to be remote access. That means once we are having the databases identified, we can probably see the particular actuation of that particular link or particular joint, how it is moving, and through the actuation of the database we can do those particular items. The other part of this database management story is the search engine. That means we may have, of course it is not a must, but we can have our specialized you can say customized data mining tools also, and these tools are of a lot of research perspective. Okay, so one such activity was undertaken by my research scholars group, which is the development of Acumine. So Acumine is a kind of a Boolean operation based search engine development. So it's a very interesting development, and this Acumines having has various Boolean logic functions like AND, OR, exact phrase in order to have the proper. And this is mainly customized for the robotic phrases. That is for, phrases related to robotics. We wanted to make it. Of course, this is in very much beta stage of now because our initial phase is working. We have interest to make it further with lot of crawlers and lot of other search engine related technology invite to that. But this is the area where people can do good research actually. So design of Acumen, that is just to make you more aware that how we have actually arrived at. There is a working formula for weightage calculation. So this weightage calculation is WKD is equal to WK1 into 1 plus WK3 plus WK2. So all those things are actually here written. That means if a keyword appears 5 times in a document and the total number of keywords in the document is 25, so how it is coming? So basically it indexes all words as document and common words can be avoided. Like that it is going, and so it is if for each search request it is calculating this weight and accordingly it is providing the things actually. So these are the some of the GUI screenshots for Acumen, how it is performing. It is also a very interesting story of our R&D in web robotics. So installations page, indexing page, etc., etc. Now, another interesting feature of this database management feature of web robotics is fuzzy operation based search. So we can have fuzzy operation based search, and fuzzy based search operation is a new concept in database management option actually. So fuzzy operation based search says that a lot of natural language processing or the alphabet listing, so those things are possible. But of course, this is a very new area. One can do fuzzy. So we are just slowly moving. There is one project initiated actually recently where we can probably have an option to introduce a fuzzy operation based searching operation actually. Okay, so we'll now move to our final phase of developmental activity in under the case of network related paradigms in web mediated robotics. So there are various issues related to network based communication, and one can have customization of protocols also in this field. Okay, so control of robotic systems through web is highly dependent on the prevailing network condition, that is its type, whether it is LAN, WAN or internet, its composition, bandwidth available, protocol use, congestion control metrics and security aspects. So all these things are very, very important. In fact, each one of these paradigms are important. So one can have a very in-depth research in each one of these paradigms and accordingly one can go. Now, from a conceptual standpoint, these issues I can group in the 3 or 4 broad paradigms actually. One is the localization of the web servers, then router grammar and combating adulteration en route, private networking for enhanced security, and wireless network. So all these domains have emerged as potential sink of promising research problems related to web robotics. The first one is localization of web servers through the dynamic port address translation or the DPAT. So that means basically a localized web server LWS is being generated. So this is a very interesting aspect. That means main web server is of course geographically apart. So we want to have a localized web server generated out of it, LWS. So this is the working model of LWS. There is a remote server, a servo pseudo server, proxy, client, DNS, etc. So this is very important for areas where security is a concern. That means you want to protect your robot, you want to protect your clients also from various external threats or the malware. Then this DPAT or dynamic port address translation or LWS, okay, local working software, localized web server is very much important. So good handshaking between the LWS and DPAT is very useful in developing this kind of thing. And this DPAT defines either 1:1 or 1:n kind of mapping between the web robots and the users of the remote robot. So where n is the number of users. That means it can have a 1:1 communication or 1-to-many also. Okay, so that kind of thing. That means if robot 1 with IP address this needs to be connected simultaneously to say 4 users, R1, R2, R3, R4, and robot 2 with a new IP address is also to be synchronized with another group of 4 users, say R5 to R8, then both of these cases are 1-to-n type mapping. And for that, this DPAT is a Very important. That means port address is dynamically translated depending upon the mapping between robot and robot 2 with an RI, how many users are connecting, getting interested to get the data depending upon the requirements. Okay. So if both the robots are say working say for one medical treatment or something like that, maybe independently, and there are four each clients are being hooked up to that, and depending upon the request of the client, that means say R6 is wanting R2 robot R2's data, or R1 is asking for robot or say robot 1's data or something like that. So depending upon the sequence, your port address is getting dynamically changed. And with that conceptual layout, again we build up a lot of practical things like starting from the initiation screenshot to the initiation process to the logging process to the web downloading option. So many things. And also it can be extended to LAN environment wherein there will be separate firewall servers also to each LAN. So all those things are possible. That means in case there are firewall servers, we can do the LWS for that also. Then the second thing that was developed by my group is called ARTPP. That means anti-routing table poisoning protocol. So this is a very, very interesting domain. Actually, a lot of things can be told about these protocols, but basically this protocol ARTPP is anti-routing table poisoning protocol. It checks for the routing or the looping of the entire transmission path in order to check for link attacks. That means when there is a long link, that means a long, you can say that intermediate servers it has to be passed, okay, depending upon your route. So it is very likely that it can get a link attack in route, okay. So it is also provided with a counter actually to check for the actual number of links or nodes visited and possible detection of fictitious links, if any. So it is actually carrying the ARTPP is already having a kind of a counter embedded in it. So that counter takes care of whether there is any link attack that is being happening in between this web server operation. So that is also another part of this thing. And besides, the protocol keeps a look for misrouting of packets and also the congestion control to some extent. So, and most of the transmitted files, or all of the transmitted files through this RTPP protocol are digitally watermarked. So this is a very, very important thing from the security point of view. So with this, because when there is a network, there is a malicious attack, there is a problem of, security problem. So we need to have this kind of a table, a protocol. And how it works. So if there is a worm or hacker in between, so that is getting bypassed to robot, this web access, and finally to the robot. So this is the thing. So we create some kind of a pseudo worm. So this is very interesting. It is kind of a antibody preparation kind of thing. So this particular protocol has got a ability to create a pseudo worm, and they resemble the instances of attack in order to test whether the implemented protocol serves this functionality as well as not. So the malicious route is getting detected, and then it gets created also. Okay. And this is the functional layout of this protocol. So there are client and the keys and the users, robot, etc. So basically, this is the whole structure. So the functional layout of the protocol consists of 4 entities like client, key, user, and robot. Okay, and each one is having also several, kind of a parts, essentially client ID, IP address, username, password. So these are the details of this. So this is a very involved project of development, and we have a lot of research issues that we solved actually. And the key table is responsible for maintaining and storing the various keys used by the clients. User table is also a specialization of the client table. It gets user ID, designation, acknowledgement store, hash store, lot of things are possible actually. And robot table is also responsible for keeping the robot specific data. It is a specialization of the client table, and there are two. So basically the idea is we have made those things as a tabular or the maybe a kind of a subgroup form, and the subgroup is attributed to several attributes. Okay, and these attributes are linked to that. That means all will work in unison. This client table, robot table, key table, user table, these four tables or the four you can say pillars of this protocol are working in tandem. Okay, then our next protocol is M2TP, Dynamic Multicast Mixer Translator Protocol. So this is another very interesting protocol. It is scalable. It can be either unicast or multicast, and you see that it is between again TCP and UDP. So some kind of a thing that we started our research through VRDP. So it is also an application layer protocol, and it is we can have this kind of a level. So application level protocol only. So with a media encapsulation in between possible. So this is as a lightweight and flexible nature, and it has been made with the protocol neutral, that is not affected by whether the transport layer follows TCP or UDP. So it is a encapsulation in the application layer only. And it also has got two basic thematics. One is the sender report, another is the reception report. In the both in this case actually we got it actually. The last one of this development is P3N, which is pilot private parallel network, which is a little different from the virtual private network VPN. Now this is endeavored in such a way so that it can cater not only to the static users but also to the mobile users. So this is very important these days, because so with the advent of technology, we can have a robot being used by the static users and also the mobile user. That means through mobile app or through the PC app, PC system, robot is being active. So there is a concept of dynamic users now. So with static and dynamic both, that is in this figure, 1 to etc. up to n as the static nodes, and 1a, 2a up to na are called the dynamic nodes. So that means corresponding 1, 1a, 2, 2a. That means 1 at this time t equal to ti, the user number 1 or the node number 1 was static, but in the next moment it becomes 1a. It becomes a mobile, or the mobile becomes static. So many possibilities are there. That is the reason we need a kind of a pilot private parallel network kind of thing, or the P3N. Okay. Now in case of VPN, what is happened? It is all virtual. This type of kind of a juggling between the static users and the mobile users are very important. So it needs a piloting actually. So that kind of it envisages creation of a pilot routing among the participating node, that is static and or mobile, before actual transmission begins along a specified path of network. And of course it is private, so it is limited to registered users, and it is a parallel system because original routing system is already there. So this is another interesting development that a web robotics can call for. So it is basically both with VPN, virtual private network, or the RON, which is resilient overlay networks. These are based on static nodes only, but P3N is essentially a combination of static and dynamic nodes. So that is the basic fundamental paradigm of this development. And it is also a quite homogeneous in action, and it is also based on fault tolerant approach. So a lot of developments have we have arrived, and many more can be doable also. Now the last one is the wireless transport protocol, WTP. This is a very, very interesting domain, and in fact the development of WTP is enormous in last decade, in fact last 10 years to be very specific, and we have also have an equal share of this development in our lab at with my group. So with wireless transport protocol, we have carried out several experiments. In fact, a lot of experiments with mobile-based wireless applications for actuation of gripper and other small robot system, and we have planned to use this for a lot of miniaturized biorobotic projects actually that was now under conceptualization stage. So the challenge here is basically the kind of a disintegration of the digital signal in the finer form, and then the D2A conversion and all those things, because we don't have the wired communication. So everything is the signal form we have to consider actually. And three basic modules are important in WTP. One is the parameter extraction module, user interface module, and communication with physical devices. And so this is a very significant areas actually. Server PC also comes in the picture. And to some extent you can say that WAP interface is but WTP interface is similar to the web interface or telephone interface to start with, but it has got a lot of other parameters which telephony or the web cannot give. Okay, and this is becoming the bread and butter of many robotic companies also in near future, because most of the applications will be through wireless mode. And this is also another example of our own initiation of wireless control based system WTP for this particular robot. Now this is another success story of ours in 2000. I think 2019, mid of 2019, we developed this patient assistant robot. This is a fully working prototype of a nice, flexible robotic systems with a gripper. And this patient assistant robot was also tried with a wireless control. Of course, initially we were with the wired control system. A lot of experiments were done through its, control through web and with WTP. Now our experiments are going on. So, and we are pretty successful in moving this robot in a forward kinematics path, and YouTube videos are also there. This is very important for small objects material handling, and it can be very much deployed under medical sector with patient assistance and healthcare, and also social sectors and home appliances also. So social sector and home appliances like feeding the elderly person, feeding a person with, Alzheimer or maybe the Parkinson's disease. So for this type of patients, feeding is a very important task, because it takes time, it needs attention also. So these robots, and probably with web-based control, like maybe the person which is attending this patient is sitting in somewhere room with a mobile device, and with that it want to control this small robo. Of course, this robo we have made in a larger dimension with a 1.5 meter reach just to check our potential, but now we are planning on another project. In fact, the hardware is will be ready very soon. This is with a single link robo system we call FewMore, and this particular project is actually in pipeline, which will be used with the full WTP, wireless transport based control. I will quickly share some of the slides on data structure. So this is another theoretical interesting study. Now, basic fundamental principles of robotic data are like that, because there can be so many variations in the data points in actually a very small domain, because this is the actual real-time operations. No? So the data points are actually can vary, and we can essentially compute something like a data center and a data cloud. Now the circular picture that is being shown is basically the data circle or the data cloud, and the data center is the DC, which is the centroid of this. So if we plot the raw data and if we group it, we can have a median value. So the most important thing is the median value and not the mean value, because the medians are very important. Now for each operation, we can have a DC and the data center data circle and the data cloud for that. And we can have even a convex hull for that. Now, if the data are not there, we can have a convex hull. So if we plot in the time domain, that is T1 to Tn, we can have in the MIMO system, as we have discussed earlier, there are several data centers and data clouds, and we can plot those things like this. And we can have some kind of a plot like this, which is a very artistic figure. And if we have a lot of input variables, I1, I2, I3, I4, like that, 4 input variables vis-a-vis the n time steps t1 to tn, each having a finite zone, we can have the data clouds are like this. And there can be a zone of pause also. That means at this zone, nobody is working. Like nobody is working means by some way or the other, no data cloud has come. That means maybe the robot is stopped at that location. Okay. So this type of parameters are possible in the MIMO-based system. And once we have this, we can have mathematical model for that, and this kind of a tabular representation or the matrix representation is possible, and the way it has been shown. That means from T1 to Tn we can have this kind of a layout. And in order to address this layout, kind of a ordered matrix, we can have mathematical description that if there is a raw data available for this time duration of T1, we put it as 1. That means data is available. If there is no data, 0. So this 1, 0 kind of matrix is being conceptualized. Anyway, so this is of course there are a lot of other mathematical part that I have omitted. Now, so basically if we see that deployment aspects of this web mediated robotics, first is the customized protocol. So the protocol that I have developed or I have described, apart from that also one can think of something, but without disturbing the basic parenthesis of the customization of the protocol. So customization of the protocol is very important, like M2TP or RTSP, etc., etc. The next group of tailor-made protocols that can be implemented, these are in the application layers, to be very specific. So customized protocol in the application layers, M2TP or the RTSP. Now customized protocols in the transport layers are something like that actually. So these are like this that without in the paradigms of TCP UDP how you can implement. And then network issues and related security measures are vital wings of the web-based robotics like P3N, ARTPP, DPAT. So these are the 3 examples I have given. One can think of some other also, but primarily these are the 3 things. So here we are having actually the things of our developments of flexible robotic systems. I am again showing the pictures with the different joints. So this has been experimented with multiple database and other things actually. So this is another success story. Gripper part we have experimented thoroughly for several applications actually. So many grippers that was developed by my team and my group and my industry associates also. So they are being shown here. We have done those things web. So all these web-based control have been evolved. So with this we can at the position of culmination. So basically the real-time assessment of the performance of the robotic systems via web or internet is the prerequisite for establishing a remote control system for any real-time application. So this is very important, and this present research build up an optimal foundation for analyzing the challenging metrics of web-mediated robotic systems using customized protocols and network models. So basically our 2 weapons are customized protocols, both in the application layer and the transport layer, and also the network models or the network-related issues. And these are some of the YouTube videos that you can watch to see the development of my group and the projects that we are doing along with our industry associates. So all YouTube videos are our own original videos, 100% authentic and original, customized, indigenous development. So we are very proud to share these videos with you. So with this, I am ending my talk, and with a mandate that let us strive to make the novel research more vibrating, so that it is a very open-end area, open-end research. So that means a lot of new things are acceptable, new things are possible, and young researchers should come out to develop the system more robust, more rugged. So with that, I am ending my talk. Thank you very much. So if you have any queries, I can probably answer quickly. Thank you.
Okay, sir, thank you. Thank you so much. Is there any question from participant side? Hello? Yes, is there any question from participant side? Okay, sir, I have one question.
Yes, please.
Sir, actually, you have talked about dynamic control and reliability of.
Yeah. Basically, this is that VRDP I was mentioning, the variable reliability transport protocol. So that protocol is having that concept of assessing the reliability that with which that transmission has to be made. So depending upon our use, like as you were mentioning, the fundamental principle is TCP is the most reliable, but it takes more time, and UDP is the so-called not very reliable and it is faster. So in between we have to place our requirement. So when we say, for example, as I was showing some photographs for our miniaturized gripper development. So for those developments, our reliability is more important rather than time. That means let it take more time to grasp that small job, small, I mean, in fact, we have tested with very small objects like a very small plastic spoon or a small cotton ball or a tablet, strip of tablets, metal, as small piece of gems clip or this kind of thing. So that means the accuracy is more important, reliability is more important in gripping, but not the time. So there we will be using the VRDP type of things, say maybe VRDP1 or VRDP2. So that kind of concept actually. So this is the dynamical you can assess. That means for this type of operation, this gripping operation, let us use VRDP1. For this gripping operation, let us give VRDP2. So which is not possible if you use our standard TCP/IP based or the UDP based protocol.
Okay. Sir, one participant asked one question in YouTube chat box that can you, sir, tell me about the robotics gripper system applications?
Yes, there are various. Of course, this lecture is not exactly for robotic grippers. I have given those photographs just for amplifying the concepts of web robotics. But there are plenty. In fact, most of my current researches are with gripper systems, and there are plenty. So depending upon the job you want to do, say it can be industrial job, it can be a home application job. Okay, and depending upon the job you want to, you have to choose your gripper. It can be job in the medical sector, like in hospitals you have to employ the robot, or you have to employ the robot in household sector or for security purpose, rehabilitation purpose. So enormous scope is there, and accordingly you have to choose your gripper, you have to design your gripper and customize your control system and maybe the web protocol also. So it is basically a designer system. So depending upon the end application, we have to think of the design and go forward.
Okay.
So with details like one can always be in touch with me and my group, and then we can develop some new things also if possible. But primarily one has to think of the application that is there for that gripper, and accordingly the design has to be made.
Okay, sure, sir. Sir, thank you. Thank you so much. Is there any other question from participant side? Yes, sir. I think there is no any question from.
Okay.
So I would like to thank sir for this wonderful session. On the behalf of this Bharati Vidyapeeth deemed to be University College of Engineering, I would like to thank you, sir, for this wonderful session. It is a great privilege to having you here, sir, for this Atal Faculty Development Program on research opportunities in robotics and automation.
Thank you very much. Yes.
We have learned many things in this session. Mediated robotics, multi input and multi output robotic system, then dynamic control reliability, real time web robotics. Also we have learned about simulation and experimentation of various robotics and gripper system and so on. So we have learned many things in this session. So thank you for this wonderful session, sir. And also I would like to thank our participants for patiently hearing this session. And also I would like to thank our principal, sir, Dr. Anand Bhalerao, sir, and head of department, Dr. KB Sutar, sir, for organizing such wonderful session. And thank you. Thank you so much, sir.
Thank you very much. Thank you very much. So hope we'll be having chances to meet and probably discuss more in person, and maybe we can engage ourselves in fruitful R&D on different areas of robotic research. Thank you very much.
Yes, sure, sir. Thank you. Thank you so much.
Thank you. I will be. I can be always contacted through email, or even you can share my mobile number to the interested faculties, and they can be in touch with me afterwards also if they feel like.
Yes, sir.
Okay.
Sure, sir. Sure.
Thank you. Thank you very much.
Thank you.
Thank you.
Hello, participant. Next session will be start at 3:30. Please be on time. The next session will be conducted by Dr. Alexander